My name is Mahesh. I am chemistry teacher. My topic is thermodynamics for 8th, 9th and 10th standard. So now first from the introduction of thermodynamics. Thermodynamics is a special branch of physical chemistry which deals with heat and various forms of work. Here, thermodynamics explains only feasibility of a chemical reaction under given set of conditions. And thermodynamics can explain macroscopic properties only, but not microscopic properties. And here, thermodynamics does not explain rate of reaction and mechanism of reaction and factors affecting rate of reaction. So then we should go through some thermodynamic terms. What are those? Thermodynamic terms means terms in thermodynamics. First one is system. What is system means? Any part of a portion, any part of a matter which is under observation is called as system. Anything, the part of matter which is under observation is called as system. So next come to the surroundings. Except to system, the remaining all in the universe is called as surroundings. Next one is boundary line. A real or imaginary line which can separate which can distinguish system and surroundings is called as boundary line. For example, this is the system we are taking here. So now this is system which is under observation, and this is boundary line, and this is surroundings. Now, based on the nature of boundary line, these systems are divided into three types. What are those means? First one, open system. Open system. A system which can exchange both heat and matter from system to surrounding and surrounding system is called as open system. So this is the system. Now here this is the open system. Now here matter can exchange and as well as heat also can exchange. So that's why delta M means matter. So is equal not equals to 0. Why? Because matter is exchanging, and delta Q means heat is also not equal to 0. Why? Because both matter and heat can exchange between the system and surroundings. And this is about open system. Next come to the closed system. What is closed system means? A system which can exchange only heat but not matter is called as closed system. So this is the system, and this is the closed system. Through this matter does not exchange, but heat can exchange like this through the walls. So hence here matter is not exchanging. So we can take here delta M is equals to 0, and but delta Q is not equal to 0. Why? Because matter is not exchanging. Now matter is not changing, but Q is changing. That means heat is changing. That's why delta Q is not equal to 0. So this is about a closed system. So next come to the third one, isolated system. What is isolated system means? A system which does not exchanges both matter and heat. So then that system is called as isolated system. So in this isolated system, the boundary lines are made up of insulated material. So this is the insulated material. So if the boundary lines are made up of insulated material, then that system does not exchanges heat, and as well as it is a closed system, and matter also does not exchanges. So hence we can take here delta M is equals to 0 and as well as delta Q is equals to 0. And here these walls are made up of, boundary lines are made up of insulated material. Means that material which does not exchanges or does not allows heat to outside or outside to inside. So this is called an isolated system. And based on chemical composition, based on chemical composition, based on chemical composition, these systems are two types. First one is homogeneous system. Homogeneous system. What is homogeneous system? Means a system which contains only one phase throughout is called as homogeneous system. Example for this is water. So the water is in only liquid state, then it can taken as homogeneous system, or a mixture of air. So here in mixture of air only gaseous phase we can observe. Any other phases are there in this. So that's why these two are example for homogeneous system. The next one is heterogeneous system. Heterogeneous system. A system which contains more than one phase throughout is called as heterogeneous system. For this example, we can take the mixture of ice and water. So in this, ice is in solid phase and water is in liquid phase. So that's why this is having more than one phase. And we can also take two immiscible liquids. Means the two liquids which cannot mix with each other. Two immiscible liquids, for example, benzene in water or carbon tetrachloride in water. So these are the two immiscible liquids and ice and water example for heterogeneous system. So next, so these are the classification of the system based on this nature of boundary line and based on chemical composition. Next one is extensive property. Extensive property. A thermodynamic variable which depends on amount or quantity of a substance present in it is called as extensive property. So this extensive property depends on amount. So for example, mass, volume, length, and all thermodynamic properties like enthalpy, entropy, and free energy, and surface area. So these are examples for extensive property, and these all the properties depends on amount or quantity of a substance. So that's why these are called as extensive properties. So next one is intensive property. The thermodynamic variable which does not depends on amount or quantity of a substance is called as intensive property. So for example, means here these are does not depends on amount then those properties are called as intensive properties. Example for this are temperature, pressure, next vapor pressure, next density, specific gravity, viscosity, next surface tension, the pH, EMF. These are concentration. Concentration means normality, molarity. So these all are intensive properties. That means these properties does not depend on amount. So that's why these are called as extension. In this is intensive properties. These are the properties of thermodynamic. Next come to the thermodynamic process. Thermodynamic process. Here there are two types of thermodynamic process. What are those means? Reversible process. First one. Reversible process. So in this process, the driving force is very much small, greater than opposing force. Then that process is called as reversible process. For example, this is a system which contains air, and this is air fitted with a piston. This is called as piston. Now here the pressure inside is P, and this acts on the piston. This is called as driving force. Now here this driving force is very small, greater than opposing force, means this force. This is the opposing force. So this driving force is very small, greater than this opposing force. So that's why now due to this phenomenon, this piston moves from here to here in one step, and again here to here in another step. Like that, here the gas can expand in a stepwise manner. Hence, we can say that in this process, maximum work is done. Maximum work is done. Why? Because here the gas is expanding in a stepwise manner. So that we can say that it is a reversible process, and in reversible process, the work done is maximum. This is the one of the process. First process, reversible process. Next one is irreversible process. Irreversible process. The process in which driving force is very much greater than opposing force. Then that process is called as irreversible process. So for this also same. So this is the system we are taking, and this is the piston. Here this driving force is very much greater than opposing force. So in this case, this piston moves in a single step from initial to final. So this is V1, and this final is V2, and this is driving force and pressure, this one, and the opposing force is P minus dP. In this case, the driving force P is very much greater than P minus dP. So then that process is called as irreversible process, and in this irreversible process, the piston is moving in a single step. So that's why we can say that the work done is minimum. Whereas in reversible process, the piston is expanding, is moving, or the gas is expanding in a stepwise manner. So that we can say that the maximum work is done. Here, the gas is expanding in a single step. That's why we can say that it is a. Here we can say that the work done is minimum. So this is the two processes which are present in thermodynamics. Those are thermodynamic processes: reversible process and the irreversible process. So next one is work. What is work means? The product of force and displacement is called as work. So W is equals to force into displacement means L. So here F into change in displacement is dl. Now in the next step, force into multiply this with A and divide with A for area. Now this F by A into dl into A. This force by area stands for pressure, and this length into area gives delta V, that means volume. So we can write this P delta V. So in this thermodynamic, work is equals to P delta V. This is work. Next one is energy. The capacity to do work is called as energy. Internal energy. Here, what is internal energy means any system will have definite amount of energy. That energy is called as internal energy. Every system has some amount of kinetic energy, some amount of potential energy, some amount of rotational energy and translational energy. These all are present in a system. So that's why some of all these energies are called as internal energy of a particular system. So from this overall we can say that totally we can say that every system has a definite amount of energy. So that energy is called as internal energy and it is represented by E. And this internal energy, total amount of internal energy of a system we cannot calculate, but we can calculate change in internal energy. Change in internal energy we can calculate, that is represented by delta E. So here delta E is equals to E2 minus E1. Next, this change in internal energy is generally calculated by bomb calorimeter. Bomb calorimeter. For cyclic process, this is important. For cyclic process, delta E, change in internal energy is equal to 0. Why? Because, for example, system is starting from here. Now, this is the first change, second change, last change, and another change, and finally, cyclic means it can reach its initial point. So, now in this cyclic process, initial and final stage both are can meet. So that's why we can say that here no change in internal energy. Hence we can take delta is equals to 0. So this is about internal energy. Next one is enthalpy. Enthalpy. This enthalpy is represented by H. What is enthalpy means? The total heat content of a system is called as enthalpy. Or one more definition is there. The sum of internal energy and product of pressure and volume is called as enthalpy. So here H is equals to the sum of internal energy E plus product of pressure and volume. So this is the definition for enthalpy. And simply we can say that the total heat content of a system is called as enthalpy. Here for initial condition, H1 is equals to E1 plus at constant pressure PV1 and at final condition H2 is equals to E2 plus PV2. This is equation 1, this is equation 2. So from equation 1 and 2, the change we can write here, that is H2 minus H1 gives the delta H and it is delta E and P delta V. And here delta H is equals to delta E plus W. Why? Because already we know that W is equals to P delta V. And this is enthalpy. From equation 3, delta H is equals to delta E plus P delta V. We know that already from ideal gas equation, PV is equals to RT. So substitute this equation 4 in 3. Then you will get delta H is equals to delta E plus delta nRT. So this is the relation between delta H and delta E. Here delta N is equals to the number of moles of gaseous products minus number of moles of gaseous reactants. Now here, for example, consider a equation N2 plus 3H2 gives rise to 2NH3. In this, delta N is equals to 2 minus 4 is equals to minus 2. Now here delta N is equals to minus 2. Substitute in this in the above equation. Substitute this in above equation. Then delta H is equals to delta E minus 2 RT. So here we can say that delta H is less than delta E. So this is example 1. Next example 2. N2 plus O2 gives rise to NO. We are all in gaseous phase. And here also all in gaseous phase. Here delta N is equals to 2 minus 2 is equals to 0. Then delta H is equals to delta E plus 0 RT. Then we can say that delta H is equals to delta E. So next to third one is the decomposition of PCl5 gives rise to PCl3 plus Cl2. Here delta N is equals to 2 minus 1 is equals to 1. Then delta H is equals to delta E plus RT. So here delta H is greater than delta E. So this is the relation between delta H and delta E for different reactions. So this is about the basics of thermodynamics.